So I'm going to finish filling this in. So at the top again, it was lines and portions of lines intersect to form angles. So make sure you have those words filled in. And then a ray is part of the line consisting of a point on the line called the end point of the ray. And it is collinear with all of the other points on the ray. And then just like we talked about over here, rays are named by stating the end point first and then any other point on the ray. So we could call it ray AB or ray AC, but we cannot switch the order of those. Everybody good there? Okay. The next one. Two collinear rays with a common endpoint are what we call opposite rays. Okay, opposite rays. We should not have our phones out. We should not have them on our desk. We should not have them in our hands. You're taking notes. That means I need your attention. Two collinear rays with a common endpoint are what we call opposite rays. Okay. Opposite rays form a straight line. Which has a measure of 180 degrees. Anytime you have a straight line and I ask you how many degrees it is or what's its measure, it's 180 degrees. Okay, so if we look at the picture to the right here, we're going to start with our point B. Opposite rays are rays that have the same endpoint but go in opposite directions. So the first one would go this way, which we call that ray BA right there. Okay, you could also call that ray BD. And then the other ray goes in the opposite direction and it goes through C, so we call that ray BC. Okay. So basically opposite rays make a straight line, which is 180 degrees. Are you okay with that? I forgot to come with your license. Let me give you a paper.
So we're on the opposite ray.
Opposite rays. Under it, straight. Straight. Everybody ready? So we got a ray named with the end point and any other point on the ray. Cannot be reversed. Then we have a pair of opposite rays that share an endpoint and go in opposite directions to form a straight line. That's 180 degrees. The next is an angle. An angle is a pair of rays that have a common endpoint. Okay. An angle is a pair of rays that have a common endpoint. Now, it is very important that we know how to name an angle, okay, because we're not only going to use it just to say angle, but when we get to our proofs later this year, which you're going to hate, we have to be able to name angles and be talking about the same thing. Okay, so I want you to look at your picture over here. Do you see the two rays? What's the end point for both of my rays? A. Okay, so there's my angle. Now, we can name this many different ways. First of all, if there's only one angle, okay, in your picture, you can name it by just the vertex, which we haven't defined yet, by the common endpoint. The corner part, yep. So if I'm looking at this, what is my common endpoint? What did you tell me it was? A, okay. So I can call this angle A. That's what that little symbol means. It looks like a kind of like a less than sign, but it's more flat than it is less than. So angle A. We could also call it angle DAB, okay, because it goes through D, vertex is A, to B. We could call it DAC. All this is written right there under your picture.
Okay, so we can call it angle A, call it angle DAB. We can call it angle DAC. And then with angles, you can reverse them. The only thing is the vertex must be listed in the middle. Okay, that corner letter has to be listed in the middle of my three letters that I'm using to name an angle. So we can switch it around. We can call it angle CAD, and we can also call it angle BAD. So several different ways we can name angles. If it's just one angle, you can use just the vertex, so angle A. If not, you use 3 points. The middle point has to be the vertex. Everybody okay with that? And then to define what we were just talking about, the rays are called the sides of my angle. And then that common endpoint is what we call the vertex. Okay, the vertex is the corner, the point that it comes to. And it even has it labeled in your picture to the right. It has ray AD listed as a side, and it has ray AB listed as a side, and then it has A listed as your vertex. Do I have any questions? Okay. The next blank that's right under that box, it says an angle divides a plane into 2 distinct parts. And we're going to talk about those. Okay, 2 distinct parts. Points D, A, B, and C lie on the angle. Okay, I'm looking at this part right here. Points A, B, C, and D lie on the angle. That means they are actually on the rays that make up that angle. Does that make sense? Okay. Points F, G, and H lie on the... Anybody want to take a guess? They do lie on the plane that has that angle. But in reference to my angle. I can't hear you. I'm sorry. My ears are so sorry. Endpoints? No, not endpoints, because a ray really only has an angle has a common index, not the vertex. How about this? On the interior of the angle, like inside the angle, right? So if you have your 2 rays, points that are in between those 2 rays would be the interior of the angle. So if we're looking at that bottom picture, then what do you think about I, J, and K? Where would they be? If they're below it, we would call it, well, kind of. Exterior. There you go. But they are on the outside of the angle. Yes, that's what exterior means, is outside. So when we're talking the position of points, it's either on the angle, so it actually is on the rays that make up the angle, or it is on the interior or on the exterior of the angle, inside or outside. Everybody good there? All right. So I want you to look at that picture. It's got a lot going on there, doesn't it? We've got a lot of angles. We're going to work this first example together, and then I'm going to give you an option to answer. Or actually, we're going to do A together, and we're going to take time to try the other 2. So name all of the angles that have D as a vertex. Okay? All of the angles that have D as a vertex. So the first thing I want you to do is look at that picture and find D. I'm going to highlight as we name them, and then I'm going to erase. So everybody pay attention, okay? Does everybody see D? Is there in the middle? So would that be an angle that has D as a vertex, the one that I just highlighted? Yes. So we can name it a couple of different ways. So this side down here, the one that looks horizontal, what 2 points are on it besides D? F and B. We can choose one of those, okay? It doesn't really matter. We can call it, I'm going to choose F. We can call it angle F. Then we go to the vertex, which is D. All right, and then we can go up to the other point on that angle, which is E. Does that make sense? Or I could switch it around and call it EDF. Or one other thing that we will need to get used to looking is, do you see the number that is inside that angle that's right there at that corner? What number? Not 6. Like highlighted in that top corner, what number is that? 7. We could also call it angle 7. You can call it by the number too, because it's listed in the picture as angle 7. A lot of the times I will number your angles and I'll say find the measure of angle 1 or find the measure of angle 2. So you got to look at what that's talking about. Mm-hmm. All right, so I have another angle. I'm going to highlight this one in green. I could go this same ray here, but then I could go out to the right. Is that a completely different angle? Yeah, so let's pick 3 points. E, D, G. Mm-hmm.
I have a question though.
Okay.
That's still vertex. I mean, that's still not
No, now we're looking at the other side. So what number's there?
I thought it was still be 7 with the poles.
7's on this side of it. I've highlighted the right side now. What number's there? 8. Yep, we could call it angle 8 as well. Is everybody okay with that one? All right. Are there more angles that are at D? Can I look? Hold on. Let me erase this other highlighting because it's going to get in my way. What about this one here? Is that also an angle whose vertex is D? Yes. So give me letters to call that one. Angle GDC. Yep. Now, do you notice this one has 2 numbers in it? We can't use those because they're referring to smaller numbers. So we can't actually name that one as a numbered angle because we've got 2 angles there. And then we've got one more. How about this angle here? Does that also have a vertex of D? Okay, how do I name it? FDC. What is the number there that I could call it? Yep. So those are all of the angles that have a vertex of D, named with either letters or numbers. Now, I could not just say angle D, because then I don't know which one of those 4 you're talking about. Everybody okay? There are actually a couple more. Does anybody see any more angles? How about this one? Does that have a vertex of D? Yeah, so we can name that one. I'm not going to, but we also, does that one have a vertex of D, the green one? Yeah. So I could also name those 2 smaller angles. They also have a vertex of D, but I think we've got enough with those first 4. So what I want you to do is I want you to find angle 2. Everybody look at the picture. Find angle 2. Name the sides. That means name the rays that form that angle. And look in your picture. Look at angle 2. All right, name the sides of it. They are named as rays. Remember, rays start with the end point and go through any other point in my angle. Some of these pictures get a little difficult, yeah.
After you take the quiz for this, are you going to add on to this, or it's going to be something different?
No, you add on. We haven't even gotten to the part of geometry that's hard yet. Does everybody see angle 2 that I highlighted? Okay, what's the end point? What's the vertex there? B. So give me the top side. It would be B, what? What is it? A, okay. And we're going to put that ray symbol above it. And then what's the other side? B, BD, or what else could I call it? What other point does that side go through? BG, yeah, okay. But the 2 sides are BA, that's the one that goes up. Start with your end point, B, the vertex, and go up to the other point. Or the side that's horizontal, you can either call it BD, or you can call it BG. Either one, it's representing the same ray. The end point of B, and it goes through those 2. Okay, try C. Name a point on the interior of angle FDE. Name a point on the interior of angle FDE. First of all, you have to find angle FDE. And then we're looking for something that is in between or in the inside of that angle. Just write it like a capital letter. Does everybody see angle FDE? We start at F, we go to D, then we go up to E. What point is on the interior of that angle? A. Is that the only point on the interior of the angle? I don't see any more listed up there, do you? Okay. All right, and then it says name all of the points on the exterior of angle FDE. So still the same angle. A is on the interior, so what points would be on the exterior of that angle? Same angle that I have highlighted. Angle A is on the interior. Yes, B, H, and C. I can tell you guys this, there's no way you can pass geometry if you're not taking notes and you're not listening and you're not trying. C, H, and G. Those are all of the points that are on the exterior of angle FDE. So far, so good. Okay, now we're going to talk about 4 types of angles. What's the first one it says? Acute. Does anybody know what acute angle is? An angle that is less than 90. So an angle that is between 0 and 90 degrees. Okay, think about it. Acute. It's a small angle, a little angle. If I wanted to draw an acute angle, I would probably draw something like that. Okay, it's small, less than 90 degrees. What about a right angle? It's equal to 90 degrees, yep. If I can get my pen to write. Now, here's an important thing. When I'm drawing a picture of a right angle, in order for me to tell you that this is a right angle, I have to put something in my picture. I have to put my little box in the corner. Okay, that little box that I just put in blue is what specifies that that angle is a right angle. It is equal to 90 degrees. If it doesn't have that box, even though it may look like a right angle, we can't assume that it is. Okay, you cannot assume anything in geometry with your pictures if it's not marked. What about obtuse? More than 90, but less than 180. So it is between, 90 and 180 degrees. And my picture of an obtuse angle would look something like that. And what about a straight? We just talked about that. 180. Okay, opposite rays make a straight line, which is a straight angle. So we're just going to put, forms a line that is 180 degrees. And you're going to have to use that fact a lot to help you answer questions about straight angles or, we'll talk about those in a couple of minutes. Linear pairs. Okay, so acute is small. Oh, it's cute. 90, between 0 and 90. A right is 90 degrees, and I'll have that box in the picture. Obtuse is bigger. It is between 90 and 180, and then you have your straight. Any questions? All right. Do you remember when we talked about congruent segments? We said they were same size, same shape. Same thing for congruent angles. They're going to be the same size, and the same shape. But then when they talk about the size, they call it the measure of an angle. That's how many degrees it is, okay? So the measure of an angle is the measure in degrees of the space between the sides of the angle, so on the inside of the angle. Angles that have the same measure are called, what does it say up top in bold? Congruent angles. And the key here is the markings of congruent angles. How do I know from my picture, without telling me in words, that my angles are congruent? Do you guys see these little curves right here? Well, it's not red on your picture, but you see those little curves in your picture? Those are the congruent markings. That tells me that that small angle STR is congruent to the other small angle QTR. Those two little curves, that's the markings to let me know that they are congruent. So when I give you a picture and in a little bit, or maybe not today, maybe tomorrow, and it has those markings and it's asking you to solve for X, you're going to look at me and say, well, I don't know what to do. And I'm going to say, what do those markings mean? If you don't know they mean that they're congruent, then I can't help you there. Okay, we got to remember that stuff. Next, it says a ray or segment that divides an angle into two congruent angles is called, do you remember we had a segment bisector? Mm-hmm. Talking about a protractor or a compass? Yeah, no, we're not going to use those. A ray or segment that cuts an angle into two congruent angles is called an angle bisector, just like a segment bisector, except for it cuts an angle in half instead of a segment. Super good. Excuse me. Let's take a look at our example. What's the first thing it tells me? In the figure, what? Ray BA and ray BC are opposite rays, which means they form how many degrees? 180. So look at your picture. BA goes to the left, BC goes to the right. All together, that whole thing is going to be 180 degrees. Excuse me. What else does it tell me? Ray BD does what? Second line. Ray BD does what? Bisects angle ABE. So let's look at angle ABE. If ray BD bisects that, what can we say about those two smaller angles? They're what? They're congruent. They're the same. So I'm going to put my congruent markings here so that I know that those two angles are the same. That's what it means to bisect something. Is to cut it in half, cut it into two congruent parts. It's all about looking at your pictures, making your marks, making your congruent marks, whatever it tells you, and then labeling everything. So let's look at what it tells me. What's the first angle it gives me? Angle what? ABD. And what does it say about angle ABD? It's 4x plus 14. So let's label that. In my picture, where angle ABD is, does everybody see angle ABD? Is that lower one here, the first one that I have with the congruent marks? The measure of that is 4x plus 14. So I'm going to put that here. And then it says that the measure angle DBE is 8x minus 32. So I'm going to label that in my picture as well. And then it wants me to find the measure of angle DBE. Before I can do that, what do I have to figure out?
Yeah, I mean, who knows what else, I mean, if I have a variable involved, I'm gonna have to figure out what that is, right? So here's a question. Those two little red marks means those two angles are what? Equal. So how am I gonna set up an equation to solve for x?
Exactly. The two angles that they gave me, so the 4x plus 14 is going to equal the other angle, 8x minus 32. I know that because it told me that BD bisected the angle, which told me those small angles were congruent, so therefore I know how to set it up. We're going to solve this equation for x now. I'm going to start by subtracting my 4x over to my 8x. Oops, that's supposed to be a 4. I'm going to come over here because I'm running out of room. Now I'm going to add my 32 over to the other side. And that does not go in evenly, I don't believe. So I'm going to give the decimal value for you. So if we divide that out, if we divide both sides by 4, x is going to equal the decimal 11.5. Did it ask me just for x? No, it asked me to find the measure of angle DBE. So I'm going to come over here to the side. They told me that the measure of angle DBE, first of all, let me stop here. Do you see how I wrote that M in front of the angle symbol? That means I'm talking about the measure of the angle, how many degrees it is. If that M is not there, then I'm just referring to the actual angle, just the shape, not how much it is. Does that make sense? All right, so they told me that the measure of angle DBE was 8x minus 32. I now know that x is 11.5, so I'm going to plug that in, and I'm going to work this out. I'm going to do 8 times 11.5 on my calculator. That gives me 92. And then I do 92 minus 32, which would tell me that the measure of angle DBE is equal to 60. That make a little bit of sense? All right, I believe that last one is pretty much just like the first one, so I want you to work on that. I'm going to go ahead and start passing out your homework so we don't run out of time. But I want you to work on that last example there. It's telling you what two angles are. You have to label your pictures in order to see what you have. It's all about looking at it. Okay, you can't just try to keep it all in your head, otherwise you're going to get lost.
Will we ever have a line check? We need to keep our notes.
I mean, you should be able to study that.
I'm saying, are we going to do line check?
Label what it tells you so that you know what to do.
Huh?
How close?
I can't hear you.
How close is it?
Oh, sorry, I can't hear. My ears are clogged. It's on Tuesdays and Thursdays.
Okay.
In the figure, ray KJ and ray KM are opposite rays. And KN bisects JKL. So that's the first thing I need to look at. Angle JKL is right here. And then it tells me that KN bisects it, which means it makes two congruent angles. That would be the first thing I do just by reading that question, marking my congruent angles. KN is in the middle, therefore the two angles that are next to it are going to be congruent. Then it tells me that JKN is 8x minus 13. And it tells me NKL is 6x plus 11. So just like the other one, what would I need to do to these to be able to solve for x? If they're congruent, I set them exactly. 6x plus 11 equals 8x minus 13. And then I can just work on solving this equation. I'm going to add my 13 over. And then I divide by 2. So what do we get for x? 12. Okay. And then it is asking me to find JKN. The measure of angle JKN is represented as 8x minus 13. So I'm just going to plug in 12 for that. 8 times 12 is 96. And 96 minus 13 is going to be, what, 83 degrees? Does that make a little bit of sense? Kind of? Somewhat?